Share thing. All right, and it's recording right away. That's good. So we are now ready for the class. All right, so let's get back to the exam one question from last time and see if we have any questions about that. So to get back to that one, I'm not sure whether it's on my screen or not. I think I might have closed the PDF already. Nope, it's still here. All right. So the only question that we did not really go through was the last one, which is question number 6. So do you guys want me to kind of fully solve, question number 6? Okay, all right. Yep. Question?
What's question number 5? Just for a double check.
Question number 5 has the same format as question number 4, which has the same format as question number 3. So in terms of format, they are the same, but in terms of the answer, they're not. So we can go over some of those too if you guys want to. But I think question number 6 is truly unique because it is a different, it's a different part of the scope of the exam. Because question number 6 has to do with alpha, the G function that we talked about in alpha. And this one is about the application. It is not about the derivation of the function G. It is about how we use the function. Okay. So let's go back to this one. Okay. So once again, this particular definition is just the function G itself, which is the same as the function G in the alpha module. And this is the only thing that I added on top of function G. And it is completely 100% written in C++. In fact, this is just plain C. I did not even use object-oriented programming or anything fancy like that. So the code here, okay, is recursive because you can see how G encode is calling G encode itself. So it is a recursive subroutine. And this is also one reason why CISP430 and 440 there's a reference to the 430. Because in CISP430, you will definitely be exposed to recursive algorithms. Have they started to do that in CISP430 to talk about recursive algorithms? Okay, very good. So this is recursive. So with any type of recursive algorithm, the first question that you need to ask is when does it stop? Okay, what is the one case or cases in some programs that it is not going to call itself? Okay, that would be the first question I would ask. So in this case, you can see that there's only one single statement in the entire subroutine, and it is the value it's returning is a ternary expression. So obviously, the first thing you need to remember is what is a ternary expression? We talked about that quite a few times already in this class. Did they teach you, the ternary expression in your other programming classes? No? I see some nods and some turning heads. Okay, so that might depend on who's teaching, but you can just look it up too, okay? Because I already mentioned this is the ternary expression, so you can look it up. So ternary expression is basically if then else, but kind of condensed into a single expression. This is the condition, this is the then value, and this part here is the else value. That's basically what it is. In other words, the same thing can just be written as if not the reference P, then return 0, else return the recursive call of G. It would have meant exactly the same thing. Are we still doing okay so far? Okay. So the question now is, when does it stop the recursion? Well, it stops the recursion when this statement or when this condition is true. This condition is saying negation, the logical negation of whatever P is 1 and 2. So it's looking at whatever P is 1 and 2 as if it is a Boolean value, which you go like, but it's not, because P is obviously pointing to an unsigned char. That is true, but in C and C++, there's such a thing called coercion, which is also known as implicit type conversion. So because we are looking for something that's Boolean, so that the Boolean negation can work on it. So that means we're looking at whatever P is 1 and 2. If it is 0, it is considered false. If it is true, if it's non-zero, it's considered true. So that means if I want not the reference P to be true, P needs to be pointing to a null character, which is the last character in the string. Is that okay? So in that case, okay, if P is pointing to a null character, I simply return 0, as the result of G encode. All right. So what if it's not pointing to a null character? Then we go for the recursive subroutine. So the non-null character becomes the x coordinate of the G function, and then whatever is the next or the G encode of whatever is after this character becomes the y coordinate. But we're still looking, doing okay with this. So one thing you can do, okay, I know during the exam you may not have enough time to do it, but if you're looking at this and you have plenty of time, one thing you can do is simply to run it. Okay, you can run it using a compiler, using online GDB or code blocks or whatever, and then you want to examine, at each level of the recursive call, what is it doing? Okay, so that's one way to do it. You can also do it by hand. Just give yourself an array of 2 or 3 characters, so it's actually manageable. And then you can just go ahead and say, okay, this is the string that I'm passing to G encode. In the first invocation, what is it going to do? It's going to do blah blah, and then in the second iteration or the second invocation, what is it going to do? It's going to do blah blah, and so on. And then you can get a better understanding of how it is encoding an entire string into a single unsigned integer. So since we do have time, okay, do you guys want me to kind of go through that process? Okay. Okay, so let's go ahead and use Joplin for that purpose. So let me move Joplin to I thought there's a way to move it to a different monitor, but I can't find it. So that's okay. Just move it manually. There we go. Okay. So we'll just go ahead and try to figure out what is G encode of. I'll just give it a string, as an array, and since it's an array of unsigned char, I'm going to say, what if it is 12 as one unsigned char, 2 as another unsigned char, 6 as another one, and then we have a null terminator of 0. So this is the first call. I know I'm not using C syntax here. I'm using JavaScript syntax here. So we have an array of 4 characters. The first character is 12. The second one is 2. The third one is 6, and then the last one is our null terminator, which is a 0. Is that syntax okay? Because it's not strictly C, but I need to kind of illustrate what is the first thing in the array. So this is the easiest way to do it. Okay, all right. Okay, so in the first invocation of G encode, and I probably want to enclose this entire thing in a code blocks just so that the syntax looks okay. So in the first one, it would become G of whatever the first character is, because the first character of this entire array is 12, which is non-zero. So that becomes the x coordinate that I pass to the G function itself. And then it's going to pass G encode the rest of the string, which is 260, as the y coordinate of what I used to pass to G. Okay, so let me just pause here and make sure that we all understand what this means. It takes the first character, make that the x coordinate of the G function, and then it's going to say, I'm going to do the encoding of the rest of the string and pass that as the y coordinate of the first invocation of G. All right. So then what do we do? Well, we cannot do anything until we find out what is G encode of 260. So that's what we're going to do. So now we have G encode of 260. That turns out to be, because this 2 here is not a null character. So that means we have to use the recursive method again, extracting the first character 2 as the x coordinate of the nested call to G. And then the rest is going to be G encode of the rest of the array, which is 60. like so. I'm just matching the parentheses, making sure that, there we go. So that cannot be resolved yet because I still have G and code 60 to deal with. So now it becomes G of 12. Okay, let me turn off the rest of the screen so I have more space here. And then G of 2, and then G of 6. And then finally we have G and code of only the last character left, which is a 0. And then we have 1, 2, 3 close parentheses. I should be missing one of them, right? Oh, okay. Yes, I'm missing a pair because I need another pair of parentheses here. There we go. All right, so we are now close to the end because G of 2, G of 6, and then this is G of 0, and which is 0. Okay, so we basically, it's just returning 0 because when the first character of an array is the null terminator, according to the code that we saw earlier, we will simply return a constant of 0. It's not even G of 0, which turns out to be. And we cannot have G of one single value, but it should simply return to 0. So this is what we need to resolve. Okay, we are basically just having a nested application of G. Okay, so we'll solve this one level at a time, and I'll pretend that I don't have a calculator. This part I can still do without a calculator. The next part is a little bit harder. It's still doable, it's just hard. Okay, so we will work out what is G of 6, 0. So G of 6, 0 has X being 6 and Y being 0. That's an easy one because it's on the base of a diagonal line, which means you have 0 plus 6 plus times 1 plus 6 plus 1. So we have 6 times 7, 42. The whole thing divided by 2, which is 21. Okay. So G of 6, 0 is 21. Okay, let me spell out why it is 21, because it is 6 plus 0 times 6 plus 0 plus 1. The whole thing divided by 2 plus 0. And that's why it's 21, but I'm just spelling it out. Okay. Matching parentheses. Look right to me. Am I missing one here? Yep, missing one. Now, that should be good. All right, so just kind of resolving one level at a time. This is 21. And now we just have to figure out what is G of 221. So that would be 2 plus 21 times 2 plus 21 plus 1. The whole thing divided by 2 plus 21. And if you are wondering, how I get this expansion here, I'm just expanding G. That's what G is. Are we still doing okay so far with this? All right. So now I have to do some heavier duty mental math. So we got 23 on one side, 24 on the other side, the whole thing divided by 2, so we have 12 times 23. Okay, fine. I have to 2 times 23 is 46, so the whole thing is 276 plus 21. So now we got 297. Okay. All right, so this is G on 12, 297. Now I might need a calculator at this point, because now I have to compute what is 12 plus 297 times 12 plus 297 plus 1, the whole thing divided by 2 plus 297. That's a typo here. It's supposed to be 7. All right, so I'm going to use a calculator because I can't do this math this quick. So we'll go ahead and use my trusty command line calculator called BC. And we'll just enter this equation. 12 plus 297 times 12 plus 297 plus 1, the whole thing divided by 2 plus 297. And it is 4. Just for the sake of completeness, it's 48,192. Right. So are we good so far? This is the application of GN code. All right. So knowing this, okay, knowing this is how we got the value of 48,192 from an array of 4 characters with the values of 12, 2, 6, and 0 as the quote unquote ASCII values. So the question now is, how do I reverse it back to 12, 2, 6, and 0? That becomes the first question, right? I mean, still doing okay. So I'm going to give you guys a little bit of time to kind of absorb this and see if there are any questions. I could have messed up the math. Okay, that's entirely possible. Questions? Does anyone want more time to think about this before I move on? Okay. So it would appear that nobody wants more time either. All right, cool. So now I start with the value. So this is the reverse operation. So the reverse operation is somehow I end up with 48,192. So the question is, how did we get here? So could I have gotten here because of a null string, which means the entire string has nothing but the null terminator? I cannot, because in that case, it would have just returned 0. So I know it has to come from a string that has something. So if it comes from a string that has something that is non-zero, or once the first character is non-zero, let's take a look at the function again and find out, how we can, kind of figure out the rest. In other words, 48,192 is this thing here. I believe I'm missing a close parenthesis somewhere. Yep, I'm missing one single close parenthesis, but nonetheless, it is it's returning G of the first character of something and the G encode of the rest of the string. That we know, right? So what do we do? What is the next thing that I need to look up for my notes? The inverse. The inverse, exactly, because this time we were given the natural number, and I need to reverse back to the 2 numbers that gave me that one single number using the G function. So now I have to look up G inverse, and G inverse is a little bit harder to figure out by hand because it has square root in it. So let's go to, and not this one. No, there we go. So now we need to look up G inverse. So there's a whole lot of derivation, but when everything is done, this is the end result, okay? Wn, which is W of 48,192 in this case, is this thing here. So this is the first thing we need to find out. So that would be 8 times 448,192 plus 1. Take the square root of that thing, subtract 1 from the square root, divide the whole thing by 2, and then take the floor of the entire thing. So we'll go ahead and do this. And this time I'm going to use a spreadsheet, just because the calculator that I have been using, that command line thing, is not going to be able to do this part. So I'm going to use a spreadsheet. Then you guys all have scientific calculators, and with a scientific calculator, you can actually do it. So here's the spreadsheet, and I'm just going to start with 48,192, assuming my math was right, okay, which I'm not 100% sure. So now the next column B is going to compute W of whatever is in column A. So if I remember correctly, it is the square root of 8 times whatever we have, as the natural number plus 1, and then we take this whole thing, and then I cannot remember the rest. Oh, it's right here. So we subtract 1 from this square root thing. Okay, so we here subtract 1 from this entire thing, divided by 2, and then we take the floor of that, okay, so we can definitely also do that using the floor function. There we go, 309. I'm not even sure whether that matched my own calculation. So now what do we do with W of n? Because that's not the answer, right? Yeah, because we're expecting two numbers coming out of it. So if you look up the notes here, or if you look up the definition of G inverse, it uses W of n to figure out what is the X and what is the Y over here. So that's what we need to do next, is to basically use this thing here. It is the product of Wn plus 3, and then the whole thing divided by 2, and then minus the subtracting of n from it. All right, so let's see if I can do this part here. All right, so this is better because I can see both at the same time. So the x coordinate, coming from the G inverse applied to 48,192 is going to be whatever B1 has times whatever B1 has plus 3, the whole thing divided by 2 minus whatever B1 is. And that doesn't make sense. Okay. Did I make a mistake somewhere?
You said minus B1 instead of N.
Sorry?
You said minus B1 instead of minus N.
Minus.
The equation says minus N.
Oh, right. So that would, so N is going to be A1. Thank you. There we go. So we got our 12. Okay, that's encouraging because the first character is indeed 12. Did everybody know, understand what my mistake was? I was using B1, and B1 is W of N, but I really should be using N, which in this particular spreadsheet is corresponding to column A. And then the other one is just using this one here. So it would be A1 minus B1 times B1 plus 1, the whole thing divided by 2, and it is 297. I vaguely remember 297. So we're good so far. The rest is actually pretty cool and easy, because now I can say, the next n I need to deal with is the leftover. It is the y from the row before, and then the rest, I can just copy and paste. So now I have just extracted the 2 in the entire array, and I can now do exactly the same thing. This time I can copy the entire row down. So now we get the 6 back, and then one more time, and we get the 0. So this is me just using a spreadsheet to show the calculation, because I didn't want to hand enter the entire thing by hand. So we're doing okay so far with this demonstration. Did I get the string back? I cannot remember what string I was using to begin with. Yeah, I got everything back. I'm actually surprised that I did not make a calculation mistake in the middle. This is why, I did not like linear algebra, because when I took linear algebra, they would give 2 different types of questions. One type is, here's a matrix inverted. And then the other type would be a proof type of question. The proof type, not a problem. But to invert the matrix, because there are so many steps, somewhere along the line, I would make one tiny little mistake, and then the whole thing is wrong. I did not like that particular aspect of linear algebra. All right, so are we doing okay so far with this? Just doing everything by hand. You good? Yep. Question?
Should we expect this on the test? Like taking code is reversing it?
All I can say is this was in the exam in the previous semester. But you do need to understand what is the G function, what it does in the context of the olive node module, and also what an inverse function is. In this case, the function itself takes a 2-dimensional coordinate and map it to a natural number. The inverse is doing exactly the opposite. Give me a natural number. I know exactly where that natural number is supposed to be in the two-dimensional space. So you do need to understand, what they mean, okay, in the context of the LFNO module. And you are definitely allowed to bring a scientific calculator. You can even pre-program, for those of you who know how to program this calculator. You can even pre-program the W function and the G inverse and whatnot. All right. Are we good so far? Are there any questions about this?
So how should,
Yeah, go ahead and then, yeah.
so the first number you got by plugging in the dark value. What? 48.
So this is the encoding, this is the decoding, and yeah, go ahead.
You encoded the so that's the n placed into the wn value, and that's what you get out of it. That's x n and that's yn.
Yep.
And then you put yn back in.
Yes, but that has the reason why I plug this y back into the n spot has to do with how this y here is the result of G encode being applied again. So the way I expanded this G encode determines how I should decode it. Yes.
So the W that is now the number that you came up with is 48,292, but in this question, the number is 2,000.
Same approach, since I have the spreadsheet already.
Or saying that that's the equivalent, right? The 2011
Yes.
number we have.
Yep, so let's see what it is supposed to be. Okay, this is why I like spreadsheets. So the numbers are supposed to be 4, 7, 2, and then an alternate. Because the structure works regardless of what n I'm working with. Yep.
And is there a preference, or do you just accept both?
Both of what?
That is both of them.
So the question, so let's go back to the question. The question is very specific. So if you go to the question is very specific that you start with a value of 2011. The 48,192 is just the example that I came up with today. Are we still doing okay so far with this? Yep.
So our explanation could just be like pseudocode and then we just give the answer, or do we have to show our mathematical?
Oh, it can be pseudocode. So you can basically write me a C function to do the reverse. Yep. So you're basically what you're trying to do is to use way 2 or method 2, which is to explain your approach to solve this problem, but write a program or mathematical definition to solve the problem. So in that case, you don't bother to actually tell me, oh, the first character is supposed to be this number and so on, because you're giving me an algorithm that after you run the algorithm, it will give me the value. The first one is more intuitive in a certain way. The second one means, oh, you're really just looking at the code here and then reverse the effect of that code. So some people feel more comfortable with working with the actual numbers and applying G inverse and then see what pair of number it returns and then determine which one is what. Some other people may look at the original code and goes like, I understand the code itself, so I can just come up with an algorithm to reverse the whole thing. So either approach is going to work. It's just a matter of, do you like empirical things and just work with actual numbers, concrete numbers? Or are you one of those people where you look at the original algorithm and go like, I know how to reverse that algorithm. Yes.
And will we be able to literally go on a computer, type into like code blocks or Replit and do this during this test?
No, it is a paper test. It was a paper test. It happened already.
in fall 2022.
So would the answer that you gave, where you stepped through all the math and you gave the equations, so we put the equations that you put into the spreadsheet, get full points, or is more?
So are you quoting the equation or are you quoting the numbers from the computation?
But we give the equations that you put in the spreadsheet and what they cover.
There's one problem with the spreadsheet approach. It doesn't know when to stop. So, so you have to explain and go like, repeat these rows until you get a 0 in column A. So that would still be an important piece because otherwise I don't know when are you supposed to stop this. So you still need to identify the stop condition if you want to use that approach.
Okay, so what if we used like a one-line approach where we're like, if you want to find, for instance, xi of n, then you put in ni, and then we give you ni, we walk through the calculation, and then that's how we get xi and n. That'll work.
Right. You still have to specify when to stop the approach because it's a repetitive approach.
Okay, so then we just need a line that's like when when n, w, x, and y all equal 0, then we know to stop and we take, x and y of n or x, all the x's.
You should say when n equals to 0,
When n
we
equals
stop.
0, we take all the x's.
Yep.
Okay. That's the same.
Yep. But I do have to warn, that I do change my questions every semester, so do not expect it's going to be the same this semester. Even though you might think it is a challenge to you, it is a big challenge to me as well, because, unlike you, which only has exposure to the one before this semester, I also have like a long list of, previous exams, and I'm not going to use any one of those, questions that I have asked in the past. Yep.
But if you use like new ideas of how to create one of these questions, you would provide the equations necessary.
It's all based on, the Aleph No module. In other words, in terms of knowledge, it will still be coming from just the Aleph No module and all the modules before that. But when it comes to, and I'm also free to use the C++ code because CISP440 is a prerequisite of this class. But other than that, okay, I would not use, I would not assume any other knowledge.
Okay.
Yep. So I think it's important to differentiate between two things. One is knowledge that is specific to a class. The other one are problem-solving skills. So problem-solving skills is kind of hard to put a scope around because, each person has a different set of problem-solving skills, and each class may teach you problem-solving skills in a different way. So it's pretty hard to put a scope around your problem-solving skills. But in terms of class-specific knowledge, I would just play by the rules. Okay, I'm not use anything other than what is in the prerequisite course of this class, and also material that I have introduced in this class up to this point. So, are there any questions about that particular statement? Okay, all right. So are we done with exam 1? More or less, or do you guys want me to kind of go back to question number 4 or 5? Because we did question number 3, we didn't do question number 4 or 5. The formats would be about the same, the scope is exactly the same, it's just that the results are not going to be the same. Okay, 4 and 5. Okay, we'll do 5 first, and then you guys can decide. Okay, I think we got enough. Please stop. Do not go back to number 4. So you guys may say, well, we want number 4 too. We'll see. All right. So question number 5 says you are given F0 mapping set A to B, F1 mapping set B to C. Okay, exactly the same setup as question number 3. Okay. Except your set A is a little bit different. It has 5, 3, and 2 in it. Set B has lowercase b, d, e, and then set C has m, r, k in it. So the membership of the 3 sets, is randomized, so they're a little bit different. But the definition of F0 and the definition of F1 are definitely different this time. So we have F0 mapping 2 to D, 5 to E, 3 to D, and then F1 mapping D to R, B to K, and then E to M. So up to that point, okay, let me put a cursor. Up to this point here, it's just giving you, what you need to know to solve the problem. So it's I have not even presented the problem. This part here is identical to question number 3, which is a notation kind of thing, because there are some people who are more familiar with the notation of applying function f to a value into an element in the domain, getting a value in the codomain in this particular format. But since we have been talking about a function is no more than a set of 2 tuples, this is the alternative way of looking at exactly the same thing. So we're still doing okay so far with that one, because we talked about that on Monday. But I just want to make sure that we are still remembering, the two things are really the same thing. It's just that some people are more used to the first notation. Some people in this class, this is the notation that we tend to use in this class. But we're still doing okay so far with that. Okay. And then the third part is still the same. Okay, so now we define F2 mapping from set A to set C such that F2 of X is F1 applied to the result of F0 applied to X. In other words, we use F0 to map X to something in the set B, and then whatever that thing is in B, we use F1 to map it to set C. So it's still basically the idea of a compound function. You use the result of the application of one function, and then you use that result, and then you apply another function on top of that. So we still okay with that concept? Okay, all right. So I'm just repeating just to make sure that we are okay with that concept. So using the set notation, it can also be expressed like this. So that means that I'm giving you 2 different representations of what F2 is about. You can choose one or the other notation. So now the first question is express the answer of F2 as a set. What does it look like? Okay. Do you want me to just talk about it, or do you want me to actually write it out? Write it out? Okay, we can do that. It's just that it's harder for me to switch between these 2 screens, so I'm going to use the copy and paste approach. This is why I really like Joplin, because Joplin makes this a whole lot easier compared to without Joplin. So I just need to pick in empty space here, do a paste. Oops, that's not what I want. Let's try another one. There we go. All right. So on the, you just have to focus on the right-hand side, and I'll be typing on the left-hand side. So F2 is going to be a set of 2 tuples, and we'll figure out what the 2 tuple is. So I'm just going to go through set A, basically it's the domain of F2, and I'm just going to go through the elements of the domain in the same order as they are listed in set A. So we'll start with 5 has to map to something. 3 has to map to something, and then 2 also has to map to something. So now we go back and then we say, okay, what is 5 mapping to? So 5 maps to E in F0, and then E in return maps to M in F1. So that means 5 maps to M. And then we have the 3 here. So 3 maps to B. B in return maps to K, so 3 maps to K as far as F2 is concerned. And then in this case, 2 maps to D, and then D maps to R. So this would be F2. Do we have any questions about, why F2 looks like this as the answer of this question? So the technique to get to this part is identical to the technique that we used on Monday, for question number 3. So everything, okay, I'm just replicating exactly the same process as on Monday. And now, in part 2, I'm asking, what is the value of P2 of blah, blah, blah? If the value is false, explain how the quantified statement, which is in P2, is false using a concrete example of blah, 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 blah. Okay. Well, I said blah, 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 because it's not a concern for me. So can you guys remember what P2 is really representing? What if P2 is true? I think it is injective. Okay, so we can look up the definition of P2. So this means, when you get your exam question, you really have to be careful and read through the instructions, because some of the definitions is in the instruction itself. So this one says, P1, blah, blah, blah. P1 means it's just a function. And in this case, every element in the codomain is not mapped from 2 or more things in the domain. So that means uniqueness, which also means it's injective. So getting back to the question, is it injection? Is this an injection? Yep, it is an injection because the codomain element mapped to from each element in the domain are unique. They do not map to the same thing in the codomain. Okay, so it's injective. And then P3, go ahead.
So for the predicates, are they definitions that we've seen before, or will you create your own that you've never seen?
Well, for this particular test, they are basically the same as what we have seen before. But I can define new predicates too. Okay. Yep. But I will only use notations that we have talked about in this class when I define those predicates. So they will be based on the quantifiers, universal versus existential, the set notation, element of intersection, that sort of stuff, cardinality, basically all the same notations that we have been introduced already. So I'm not going to throw in something that you guys have never seen before in terms of the notations and the symbols. There was another question. Oh, okay. All right. All right, so P2 turns out to be true. So we'll just say P2 of F2AC is true. So there's nothing that I need to do because according to the question here, I only need to explain if the value is false. In this case, the value is true, so I don't have to explain. So now we have to move on to P3. So P3 applied to F2, which is the function. A is the domain, C is the codomain. And now we have to find out what is it supposed to be. So P3, if we go back to the question here, P3 is asking, is every element in the codomain mapped to? I don't care how many times, okay? You can have everything, you can have like multiple things from the domain mapped to the same thing in the codomain. I just need it to be mapped to. So that means at least one, okay? At least one element in the domain has to map to every element in the codomain. So that's surjection. So the question is, well, is the function that we are defining, which is F2, a surjection? So we have to kind of check now because C is the codomain. So C has M, R, K in it. So are they all mapped to? Yep, 5 maps to M, 3 maps to K, 2 maps to R. So the answer is, yep, it is also a surjection. And since it is already true, I also do not have any explanation to do. So that's the answer.
So that means the function is also bijective, which means
It is a bijective.
so which means it has an inverse.
Yes.
And what is the inverse of 50? We just move this up to inverse.
Yeah, F2 inverse is equal to F5, K3, R2. Yep, you just flip, for each 2 tuple in the function, you just have to transpose, the first and the second element. Then you have the inverse function. And the inverse function is also guaranteed to be a bijection, which is not really surprising, but noteworthy. But yeah.
But you can only create an inverse when it's bijective, right? The original
Yes.
function.
Yep. So But that's a very good observation. Why is it only when a function is a bijection that we can have an inverse function? So you have to ask yourself, what if it is not an injection? What's going to happen? And then you ask the other question, what if it's not a surjection? What's going to happen? And you will find out, if you just give yourself an example, you will find out really quickly, going, oh, that doesn't work. Okay, if the function itself is not an injection, even if it's a surjection, it's not going to work, because the inverse function now would have to have one element in the domain mapping to at least two elements in the codomain, which makes it not even a function. Now, what about surjection? So if a function is not a surjection, even if it is an injection, that means something in the domain maps to nothing in the codomain. So it's not even a function to begin with. So that's why, a function needs to be a bijection in order to have a inverse function. All right. So we good with the exam, or do you guys want me to go over question number 4, which is kind of the same thing, except has some slight variances in it. Okay, so we do have some people wanting number 4. That's okay. I mean, we can go ahead and talk about number 4. Oh, my battery is fully charged. Nice. On Sunday, my computer just completely crashed out, as if there's no battery inside, and the power button would not turn on the computer either. I had to disassemble my computer, unplug the battery, and then plug it back in, and everything came back to normal. The kind of stuff that I actually do at home, right? I mean, just take a screwdriver to my laptop computer, it's like, I'll just take it apart and fix it. That's the reason why I took computer science as a major, so I can fix my own computer. Save a lot of money. No need to have a sweet, geek squad to take a look at all my files.
Did you ever check?
Huh?
Did you ever check what kind of phone?
Yes, I did. My wife's phone battery was not charging, or the capacity was really low. And I opened up the phone and changed the battery. Now that was an exercise, because unlike my computer, which had a lot of screws, the cell phone used glue. So now you use that card thing and try to peel off the battery without breaking the screen, because as you pull it, it would give you can exert enough torque to actually crack the screen. Then you have to replace the battery and the screen.
Did you use the air dryer or the heat gun?
Yeah, I have multiple heat guns at home, so I was able to use the heat gun to make it easier. It's still not easy.
Yeah.
So I did it for the experience. Now that I have done it once, it's good enough. It's subjective, very good. All right, so this is the last one, which is number 4. So I'm just going to be really quick about this one. So if you look at the functions, you have F0. F0 itself is a bijection. F1 is not. So F1 is not injective, it's also not surjective. So that means F2 is not going to be bijective. And then in which case you have to explain why it is not. So the reason why it's not is because, let me see. So D and E both map to Q. So that means 3 and 0 from A would also map to the same thing in Q. And then if you look at the codomain, M, let me see, yes, M is not mapped to at all. So that means, if you look at the answer, it's going to fail P2, it's going to fail P3 as well. But then you will have to explain to me why it is failing, P2. So the reason why it's failing P2 is because it maps both. Let me look at this again. So it maps 3 and 0 both to Q in the codomain, and that's why the cardinality of the set is not less than or equal to 1, and that's why it failed out. So for P3, it's failing because if you consider the codomain element of M, the cardinality of the set would have been 0, which means it is not greater than or equal to 0. So those are the reasons why it failed P2 and also P3 as predicates. Even though F2 itself is a function, it is not a bijection. It is neither injective nor surjective. Yep.
I have a question just regarding the specifics.
Mhm.
So when we answer this question, can we just write in plain English that F1 fails under, both D and D max the same element? Or would we have to go back to the predicate function and write under?
You do not. So what you do need to know, let me know is how it failed. So which elements from the domain map to the same thing in the codomain? You also have to explain to me in the other one, which element in the codomain is not mapped to. Correct. But then the question asks, explain how the quantified statement is false. So you still have to relate it to the cardinality, because if we are comparing the cardinality of the set to the less than or equal to 1 in one case and greater than or equal to 1 in the other case. So you still have to explain, in this case, the cardinality would have been 2, and hence it is not less than or equal to 1, and then in the other one, it would have been 0, which is not greater than or equal to 1. So you still have to be consistent with what I'm asking. It's just that notation-wise, you can use natural language instead of all the weird math symbols. All right, are we okay so far? Ready to move on to new material? Okay. All right, so one more thing before we go forward, I'm gonna take roll because I haven't taken roll for a while for this class. So we'll go ahead and just take roll as a kind of like a short break, if you will. And then we'll move on to relations. Yes, I have to move that one, don't I? To some people, this simply means that they can procrastinate for 2 more days. All right, there we go. So 22nd is correct, right? Because today is the 15th plus 7, 22nd. So that will be correct. This is also why the exam is going to be on the Wednesday.
Next Wednesday.
Sorry?
Next Wednesday, right?
No, the following. I have to move it all the way to the Monday. Sorry, it's the Monday. Okay, let me double check. Because originally I wanted to do the exam one next Monday, but I cannot because next Monday is a holiday. So it'll be the Monday after next. We cannot do it on Wednesday because I still want to go over the answer of this assignment before I give you the exam, because it is still within the scope. I don't feel comfortable, giving you an assignment, not talk about it, but have the same content in the exam.
So you're gonna postpone until the Monday after that?
Yep, the Monday after next Wednesday. I think I put it in the calendar already. So let me double check on that one. All right, so where's my calendar? New calendar. All right, so this is okay. Let me talk about this one because I think I sent you guys an announcement, but some of you may have missed not one but multiple announcements. So it did not show up here. Okay, this is the 22nd, so the exam is supposed to be on the 27th. So let me create it right now. Exam 1 on the 27th, And I'm gonna talk about this, in just a little bit here. So I'm gonna put in the times. So this is 1:20 p.m. And Canvas does not like 24-hour format. I cannot use the 1300 hours. Don't know why. Go, and then we submit. There we go. Okay, so this is important. I think it's important. Because you can actually click on calendar feed and integrate the Canvas calendars into your mobile device. Okay, it will give you like, okay, let me just kind of click on this. It will give you a link here, and there are ways to integrate the calendar in Canvas into your Google Calendar. And it's really handy if you have a mobile device, because what you do is on the mobile device, you link your mobile device to the WID at apps.reals.edu account. And then when you do this step here, everything, all your homework assignments, the due dates, everything on the calendar, they will show up on your calendar on the phone. Because your mobile device consolidates all the accounts, all the calendar events from all the accounts into one single calendar. So that makes it really easy to just kind of unlock the phone and be able to tell what is due on what day, along with your other calendar events. I find that to be really helpful. So, yep. Oh, because I have not, because I got distracted. Yes, I got distracted, which is nothing new, is it? All right, so the calendar, the road taking thing is for today, and I moved it to road taking here. You cannot see it yet because I have not shown you the access code. So I have done something. So let me first show you the access code. It is SDF1. Okay, I'll put it on the whiteboard. SDF1, or in lowercase. And yes, I have joined the 21st century. Oh, just won't scroll the way I want it. There we go. Is it over? Oh, access denied because I have not released yet. Sorry. Okay, don't go anywhere. I just have to release it. Give me a second here. Save and publish. Forgot to do that. There we go. Okay. Refresh your browsers. It should work. This is the century, or at least decade, of short content and QR codes. Subway surfers. If something involves 3 sentences or more, it's too much. That's pretty much every single textbook in STEM. Does it work? Is it working? All right. Great. So.
Is that supposed to be?
Sorry? Say it one more time. The access code is SDF1. Yep. Just want to see what it is. The reason why it is SDF1 is because SDF1 stands for Super Dimension Fortress 1. Which is from Robotech or Macros. And the reason why I use it is because the G function that we have talked about, it folds space, which is why this particular fortress is able to teleport itself to other places, because in both dimensions. Yep. Yes, okay, so I can talk about that too. So the CIS department is due for a program review, which means, I need to make a 7-year plan for the department to do things to help with our programs and make sure that, we are serving students and also, help to improve the student success. So the survey includes the questions where you can express your preferences. Okay, do you like or is a video recording of the lecture useful to you? You can say, nope, have never seen it, do not need it. Or you can say, yep, this is really useful to me. So that way, I can tell my colleagues, what works and what does not work, what's worth doing and what is not worth doing. And it applies to the entire department. So this is not my personal review, which is also due this semester. So later on, you'll get questionnaires that are specific about me. But this one is about the whole department. All right. Are we good so far? Rotating stuff, okay, all right. So we're gonna move back onto relations, okay? So relation is, so I'm gonna just read this part here. I hope some of you have at least read ahead of the class a little bit and at least got into this portion, and reading ahead is really important. If you want to be successful in the STEM field, especially after you transfer. Okay, because after you transfer, you will not be in the community colleges anymore. And then the expectations from the professor would also change accordingly. All right, so I'm just going to read this part. A relation is technically whether two elements of a set are related or not. So you would ask, related how, right? Well, it doesn't matter. You can define the relationship itself. Of course, this doesn't really say much, but that's the whole point. So we can consider a relation R that is defined over a set X. So that means R is the relation and its relating elements in X. Okay. The first thing that we know is R is a subset of X Cartesian product with X. You will probably recall and go like, oh, but so functions are kind of the same thing too, right? Every function has to be a subset of the Cartesian product between the domain and the codomain. One huge difference here is you don't have a domain versus a codomain. They are both just the set X. Okay, so that's one major difference. And then on top of that, there are no extra requirements to be a relation. So there's no such thing as every element has to map to one and only one element. Nope, no such requirement. Okay.
Can we say anything that's not a function is a relation?
Anything that is, no, a function can be a relation too. Because a function, okay, so it depends, okay? Because if you have a function where the domain and the codomain are the same, you can look at the function as a relation. They can be. Okay, let me give you a definition. I've just used a whiteboard to be quick here. So I can define a function where it maps natural numbers to natural numbers, okay? And so see, same thing, right? And I can define f of x to be just x itself. Is that a function? Yes. In fact, it is a bijective function. Is it useful? No. But it is a function. It is still, this f here is still a subset of n Cartesian product n. So it is a function. But the same set can also be seen as a relation in this case. So there are no restrictions in the relation about how things are mapped from the domain to the codomain. Because there's no such thing as a domain and a codomain in the relation. Okay, so I do have to kind of talk about, so tell me about the application of relation, because otherwise it's like, why are we talking about this? So I'm going to talk about an example. Okay, so let's just say that you work for Riot, okay, the game publisher, and they want you to develop a way to select gamer of the week. That's your job. Okay, is to develop an algorithm or the logic to find out who is the gamer of the week. Okay, so now you start to think about, okay, so what is important to be elected as the gamer of the week? How many hours does this person spend on League of Legends, okay, for the other game. How did other players, rank this particular player? Okay, super salty to super friendly, okay? KDR, kill. Yeah. Mhm. Yeah, KDR, okay, because you can have someone who's totally like, super friendly, but, the KDR is like awful, right? How much money did this person spend this week? Okay, I'm buying every special skin that comes into existence. Okay, all the specials, all the Valentine specialty skins, I'm gonna buy every single one of those, okay? So how much money is this person spending? So you can now have all of these things and you come up with a complex, algorithm, a function that returns true if and only if this player is ranked higher than the other player, or it gives you some kind of metric, okay? But if you're not careful, you may not end up with a totally ordered relation, which means you can say, oh, this player is better than this player. This player is better than that player. But these two players, you cannot relate. You cannot tell which one is better. So that would be a partial order. And in a partial order relations, you cannot find the player of the week. You can find multiple players of the week, but not the player of the week. Okay, so you would have failed your mission because your company or your employer wants you to find one single player of the week, and your function is not totally ordered, and as a result, it cannot find the player of the week. So that's the context of why this stuff is important, because in the end, we want to be able to define what is totally ordered. So in a system that is totally ordered, it means we can sort. Okay, if I give you a bunch of stuff, okay, and I say, okay, sort it. And then you can say, oh, are we going to go for non-decreasing order or non-increasing order? Once I specify that, you should be able to sort. With a partially ordered relation, you cannot sort because there are items that you cannot relate. Is that okay? Okay, so let me give you an example of why there are cases where you have items that you cannot relate. Okay, so the best example is to use a beer commercial. So I'm gonna look for beer commercial, smooth, but not rich. There we go. That should be able to find it. There we go. So this is rather funny. Right, so let's play this. There we go. Okay. So even though they did not mention anything about discrete structure or logic or relations, they did basically imply that rich and smooth is the best. Not rich and not smooth, that would be me, is the worst. And then in between, you have smooth but not rich. And then you also have rich but not smooth. But those two, you cannot rank them. The commercial did not say anything about which one is better. The beer is the best, right? The guy driving a sports car versus the guy driving the old beat up car. There was no implied comparison between those two. So as a result, it is a partially ordered system. It is not totally ordered because I cannot differentiate between the ordering between the four possible cases. Is that okay? Does everybody kind of now understand why we can end up with a system where you cannot really compare every single element? Is that okay? All right, so the entire idea of what we are doing here, okay, is to find out, okay, how do we, okay, where's my browser? I think it's this one. I just have to close this first. There we go. So the objective of this entire module is to mathematically define a relation where it is totally ordered. What properties are we looking for in a relation that is totally ordered? Is that okay? Now, unfortunately, this class is not a Tuesday, Thursday class because yesterday was Valentine's Day. It'll be very funny to talk about relations in the context of Valentine's Day and then talk about totally ordered versus partially ordered. And then the other properties are very funny too in that context. So I kind of missed it by one day. Dang it. All right, so we can look at a concrete example, which is less than. So in this case, less than is a relation that is defined the set of integers or can be defined over the set of integers. So 1 is less than 2 is true, which means if you want to look at a relation as a set, it means 1, 2 as a two tuple is in the set of the less than relation, because relation is also seen as a set of two tuples. 1 relates to 2 using the less than relation. That's basically what it says. Yep.
That's just assuming that we do like X is less than Y, and then like the first element of the two.
Yes.
Yeah.
Yep. And that's why we use tuples and not set.
Oh.
Because which one is the first element versus which one is the second element is significant.
Yeah.
All right. So this is just an example. And then we can look at a random example. So today we just kind of want to go through the terminology. And then next week, next Wednesday, because I kept saying Monday. I might actually show up on Monday too, because I will probably forget that Monday is a holiday and just go here and go like, wow, I can choose my parking spot anywhere I want. Yes. What? 1 and 2 are the element of distance. Because I'm looking at less than as a relation defined over the set of integers. Okay. So what does that mean? What do I mean by a relation defined over a particular set? It is a subset of the Cartesian product of integers and integers in this case. But what is in that particular set? 2 tuples, right? It's a subset of all the possible 2 tuples between integers and integers. So if I look at a relation as a set of 2 tuples, then 1, 2 is going to be an element of the less than relation. Because that particular set, the less than relation, is going to contain all the 2 tuples that I need in order to define what integer is less than what integer. Obviously, it's going to be a set of infinite number of elements, but that part is not important to us. What is important is I'm looking at relation as a set. Okay. So section 4 talks about a really random example. I don't even know what A, B, C, D are representing, but it is in the set X. And then we now define R as a relation over X. Okay. And this is just a random choice. Okay, so do not ask me why A is in here and so on. But what we can tell is A relates to itself. So an element can relate to itself. In the set of less than, an integer does not relate to itself because an integer is not less than itself. Okay. So in this case, I just choose that A relates to itself, A relates to B, B relates to C, B relates to D, and you can also see that B relates to A because it is directional. Just because A relates to B does not B relates to A. So those are 2 distinct, relations. Yep.
So you get to choose the Cartesian product basically.
Well, this only has to be a subset of the Cartesian product of X and itself, which it is in this case, right? Because if X has A, B, C, and D, then we can say every element in R is also in the Cartesian product of X and itself. So the terminology is, you can say A or B is true. So R as the name of the set can also be seen, quote unquote, as an operator. Okay, that's one shorthand. You basically say A and B are related. You can say BC as a two tuple is in R, because this time I'm looking at BC as an element of the set. We're using the element of operator here. We can say BRB is false because I do not see BB as a two tuple in the set. And then BC is in R is also false because the BC as an element, as a two tuple, is definitely missing from R. So this section here, four, is really just talking about the notation and also how do we express whether something relates to something else in a particular set. Yes, go ahead.
Just stick it into variable values to define if it's relation, as relation or not.
It's just a notation. This is just a notation, of whether A and B relate using R. Which also means whether AB as a two tuple is in R or not. It's just a different way of saying the same thing.
And that notation is the order in that.
Yes, the order definitely matters. Okay, that was another, yeah, go ahead.
How would this affect like three other choices?
It does not use three tuples because the relation itself has to be a subset of the Cartesian product between X and X. So as a result, it is always a two tuple that we look. It has to do with the definition of what makes a Cartesian product. There was another hand earlier. So who has a question? I guess we're too close to the end of the lecture, so yes, go ahead.
I do have a. Probably make something.
That's entirely up to you. So in the case of the beer commercial, we have the four elements, right? So each one element is smooth and that's my son, he needs to be picked up, but he can wait. So we have the four elements in that particular set, okay? Smooth and rich. Not smooth but rich, rich but not smooth, and then we have not rich and not smooth. So those are the four elements in the set. The question is, which one relates to which one? So I would call that relation at least as good as, okay? So that means I can say not smooth and not rich is at least as good, no, the other way around. Rich and smooth is at least as good as rich but not smooth. I can say rich but not smooth is at least as good as not rich and not smooth. Do you see what I'm talking about? So how you form the two tuples in the set really depends on what you want the relation to express. So there's no specific way that we want it, but we can characterize the relation using the terminology that we'll talk about next Wednesday, so that we can eventually define whether a relation is totally ordered or not.
Always good.